So yeah, how about that? So much for troubleshooting, so much for a next video where I have to go through. Some of you may have been looking forward to that, but I'm not, because I don't have to do it. I am ecstatic. Hey guys, welcome to the garage. We have a slight break in the weather. It's right about the freezing point of water right now. So I'm out here just straightening things out a little bit. And in particular, I want to attempt to pull down that Hewlett-Packard box up there. The contents of that, I don't think I've seen the light of day in about 20 years. I kind of forgot I had it, but I just so happened to be chatting online last night, and we got to talking about CRTs and display technologies and this and that, and I remembered I had this. I've never shown it to you guys. It's really cool, but it also has a problem. I mothballed this years ago because, well, it was beyond my means. So let me take a step back. We'll get to what's in the contents. I know you want to see it, but I'm going to give a little bit of backstory first. So I used to go to a lot of ham fests back in the 80s into the early 90s, back when there were a lot of ham fests that had really good stuff. This, I think, is the only thing I have left, along with the box next to it, the 12 FP7, from back in those days. I used to have all kinds of cool stuff, and one of the things I was working on when I was young and had energy and was kind of crazy was building my own video game, like sit-down console thing, but using vintage parts. Like I had some military surplus stuff, like sort of a gimbal joystick kind of controller, and just like parts out of tanks, that kind of thing, like the pedals. Steering thing. I had a radar display with an orange phosphor thing with a rotating yoke around it. And this. This is an XY monitor from Hewlett-Packard. Super high-end, super high quality. But in order to get it down, I need to move this stuff. Now that's on wheels, that's easy enough to move, but this is a dilapidated protogram that's still out here. And a bunch of picture tubes, so I think it's time to rearrange things a little bit. And just like that, we're in. Man, I really gotta go through and part out some of these chassis. I think I'll donate this scope to the early TV museum in May, but here, I'll finally get my hand on it. Alright, mission accomplished. It's heavy and it comes in this gigantic box, but in my mind I thought it was bigger than it actually is. And it's still big and impressive, but it's not quite as big as all this packing makes it seem. I believe it's 14 inches diagonal. I thought it was 17 in my mind, but still, it'll be more impressive when I get out of there and you guys can take a look at it. I think I'll leave the box in the garage, save myself some space inside. I also hope it still works. Alrighty, here she is. I'm going to put it down this carpet scrap, which I highly recommend for working stuff like this. So you can move it around, you won't damage anything. Now, up until recently, I knew almost nothing about this because I've never seen another one for sale. Never seen another one demonstrated, no magazine articles, anything like that. It appears it came out of some type of nuclear research facility in Ohio, according to the label on the box. But now that I saw, well, of course, back when I got this, there was no internet, so my research was limited. But now I can Google it and find some more info. So there was a cool plastic housing stand for it. But I don't know if this ever had one, because it has this nice simulated wood grain on it. Kind of looks like it was about to slide into something, so maybe they had different options for the enclosure or no enclosure. I don't know. The one example I found of somebody actually using it, it was hooked up to a spectrum analyzer. And they show it next to the built-in display, and it's comical because this is so much larger and it looks so much better. And that's part of why. It's an electrostatic rectangular CRT, and it runs on, well, this is 24,000 volts. The advertising blurb said 28,500 volts. Either way, That's a lot of volts, especially for an electrostatic CRT. Now what I find interesting was another discussion I was having recently about a 20AP1 CRT, which was a very, very early Dumont pre-war electrostatic CRT. They used in some TVs, and they had a demonstrator oscilloscope, apparently, that they used it in. But I looked up the data sheet for it, and the higher the accelerating anode voltage, the faster those electrons are flying, the harder it is to deflect them. So in this CRT, the old Dumont CRT, which was comparable size to this, if you ran it at 8,000 volts, which was the max, it took 110 volts on a deflection plate to move the electron beam 1 inch. So to go all the way to one side or the other would take a couple thousand volts. Unless that's even higher anode potential. But this is all solid state with transistors. So how, are they putting thousands of volts on those deflection plates? Well, there are other ways to get around that a little bit. One is to do post-acceleration, meaning you save the very highest voltage for the furthest away. In other words, it's already been deflected by the time you get to it. Another is where you put the deflection plates. So if you look at that Dumont one, the deflection plates are way near the electron gun at the back. And here, in high-end oscilloscopes, you'll see that they actually have pins coming out of the neck further down. So they're deflecting it here. Lower capacitance, stuff like that. At any rate, we have two identical circuits here. One for X, one for Y. Move the beam left, right, up, down. My horizontal deflection works, vertical does not. You get zero deflection. I think these two circuits are identical, symmetric. Back in the 80s, I didn't have the service info for this. I couldn't Google it. I wasn't likely to find it at our local library. But now I do. So I can go through it. I think what happened is I fried it, and I'm hoping the problem is right at the front end. Let's take a look at the manual for a moment. Here's one configuration with the plastic covering and a stand. I'm sure they had a rack mount option as well. Give you some basic info and some specs. So bandwidth is DC to 5 megahertz. Writing speed 25.4 centimeters per microsecond. Deflection and so on. Bit over my head. Okay, so the two input impedance options are 50 ohms and 10K, shunted by 40 picofarad. Maximum input plus minus 50 volts with 10K, or plus minus 5 with 50 ohm. So I think that's where I messed up, and I damaged something. Alrighty, this is dated Feb 1980. Some of the other options here, like you could get it with P4 phosphor aluminized, which would be what black and white TVs use, or P39. It says in lieu of P31. So I think P31 is blue, and I think that's what I have. A bunch of other options. Installation. This is what they call the operator service manual. So after we get through this, performance tests, they should have schematics in here. Got some parts locators. Alrighty. Adjustments. Now, assuming I got this working perfectly, what would I do with it? Well, potentially you could replace my WaveTech 1901 and I could use it for alignments. It's massively overkill for that. And there's no grid on the front, so that wouldn't necessarily be ideal. And if I have the spectrum analyzer that can be paired with this, and draws text and waveforms and stuff like that, that would be cool. But to get a fully functioning spectrum analyzer, that would not be cheap, and it would not be small, and I don't really need one. Oh, that's fun. You can write a little program. I think that's BASIC. Or is it some Hewlett-Packard language? Well, I'm not sure what this program is for. I mean, like what you would send, like program this and send this to, but apparently it's something that would generate output waveforms such that it would draw these patterns on the face of the CRT. Okay, now we're getting to exploded diagram. Hopefully we won't have to go in that deep. Parts list. I imagine it's going to be kind of extensive. And a block diagram. So, yeah, potentially I blew out one. Let's see, so it's the Y that's gone, so potentially I blew out that. There are a bunch of transistors and an input amp, an output driver. So one thought I had, if I can identify some key points, is if I think this is bad, can I feed a signal in shortly after that? It looks like a output's differential, and then it goes to probably eventually driving the two output plates. So I don't think I can just inject one signal here. It's got to be two signals that are 180 out of phase with each other. That could be a little tricky. So here's one of the input amps, I guess. It's nice, we got principle of operation. Parts locator scan is kind of illegible. That's not so nice. Okay, so schematic. So it's gain and position, which will be offset. Sorry, here's the actual input. And depending on that switch, there's the 10K, there's the 50. Yeah, I figured it would have clamps to protect this, so you shouldn't be able to put in a signal such that it would damage the FETs. Just like I thought they had FETs there, because these should clamp it so it could only be between -5 and 5. But I'm hoping my problem is somewhere in here. I'm somewhat limited in what the equipment I have and debugging, but for sure we can feed a signal in and take a scope and probe around, and then, you know, the problem is very obvious. We feed in a signal, it's not making it to the screen, so somewhere between here and the CRT, the signal is going to stop. So at least we should be able to isolate it pretty quickly, assuming I can get a key test points while the board is in the device, which may or may not be true. I hope I don't have to get an extender or something like that. I dealt with this stuff with my 8662 RF generator, where it uses a bunch of cards, and when the cards are in the device, you can't probe anything, so you get these special extenders so the card can sit up higher and you can probe around it. But hey, having this is a dream. I mean, this should be everything I need to know to fix it. Got it up on the workbench, about to power it up for the first time in about 20 years. Last time I turned it on was to take some photos because I listed it for sale. I don't recall what I was asking for, but I don't think it was a whole lot. It might have just been $100 or something like that, and I'm very glad I had no takers. Now, when did it last work properly? That was more like 30 plus years ago when I screwed it up. At least I think my memory is a little fuzzy. It happened a very long time ago. I've just been briefly reviewing this, and a few notable things. One, I just mentioned about potentially needing an extender card to troubleshoot it. there's one here. There is an extender board. All it is just a pass-through connector, but it gets the board up higher. I don't know if that came with it or if somebody got one at some point because they were troubleshooting it, or what was probably included with it, which is awfully nice of them. But something else, I thought that both these channels were identical. And sure enough, this board appear to be the same, and the board next to it here and here. But the outer boards are not. Check out all the trimmers on this guy. Kind of ridiculous. The outer board here is different. So I don't know if they're different functions or if one channel has more sensitivity or something than the other. I don't think so. I think it's these inner two boards that are the amp. So this would be the power output amp, which is just ludicrous. We have 8 power transistors with heat sinks on them, so that, and it goes right to the deflection plate. So obviously this is a deflection amp, and so is that. Next to it is got to be the preamp attenuator board, which is where I think the problem lies. But the other two boards, I don't know what those are. There are a few interesting circuits in this that might be what these are for. One of them is a phosphor protector. So the problem with XY, potentially a problem with XY monitors, is if you're not powering them with active signals, the beam will stop moving and you just have a point. If they're both 0 volts coming in or DC voltage, you just got a bright spot at one point. And this thing runs on 25,000 plus volts. Yeah, it's illuminized, but eventually that super energetic electron beam is going to burn right through that and destroy the screen at that point. Or if it's scanning very slowly, a very low frequency on one of the channels or both, it's supposed to detect that and compensate for it and lower the intensity of the beam automatically. So that could be what some of the circuitry is for. There's also astigmatism correction. It might have something to pin cushion correction, that kind of stuff. That's probably what some of this is for. Because this is all symmetrical coming in, deflection plates and all that, but at the end we've got a rectangular screen. It's wider than it is tall. It's got corners. It's not like a circular screen where everything is equal potential all around. So it's hard to do that, be it magnetically or electrostatically, to get a perfectly sharp, focused, really nice beam at every point on the entire screen. So I'll shut up and try turning it on. So first off, this thing is turned off. Let's dial our variac into about 120, and here we go. On. Sure isn't drawing much current. In fact, it's not drawing any current. Let me check the fuse and make sure I got everything hooked up right on the back here. So that's in. That's the line on. This guy out. There's the fuse. Set for 115 volt operation. The fuse is good. It's not going to draw a whole lot of power, but the needle should move somewhat. Have this in all the way. On. Oh, okay. That turned on. Man, that high voltage, instant static electricity field. Bam. Yeah, it's not like tube stuff I'm used to where it's got to warm up. This is just on. So let's try that again. Yee. Alright, it's drawn 3/4 of an amp. It seems reasonable. Turn it back off and rotate it around so we can see the front. All these controls are labeled, which is nice. So here we go back on. Now I have no signals in, so we should just get a tiny bright spot somewhere. The CRT filament needs to warm up, but none of the other circuits do. So let's see. X and Y position, trace and focus. Which one of these is about intensities at the very bottom? Oh, and we have a dot. We have a dot. Y position, yes. And X. Beautiful. Alright, I've pulled out 2 audio frequency generators. Let's hook them up and let's see if we can get that beam to move around. Hey, who knows, maybe it's fixed itself with that long hibernation. I took a close look at those 2 slide switches. One sets the input impedance to be 50 ohm or 10K. I set it to 50 ohms because I'm using a WaveTech 132 function generator which has 50 ohm output impedance. The other switch enables or disables the phosphor protection. Now that impedance switch is only on this board. There isn't a switch on the other side, which makes me really think that this board must be the input attenuator amp for both X and Y channels on one board. So if I need to still do some troubleshooting on the inputs, that's going to be the board to go after. Let's see, I have this on the X input, I do believe, which should be functional. Let's power this back up and see what's what. Make the hair on your arm stand out a little bit. Now it should be dimmer if this is working because now the beam's moving back and forth, so I should have to turn up the intensity a little bit to see it. That's interesting. Nothing now. I wonder if that's because of the phosphor protection, which actually was turned off and I just turned it on. Maybe this signal isn't strong enough and it's cutting down the brightness. Let's see, here's the coarse output attenuation. Oh, that's interesting. Man, I forgot how to use this thing. I forgot which is the output level. Let's try some stuff. Now, this is frequency. In sine wave mode. Increase the frequency. Oh, there we go. So if I go to the low, really low frequency, the beam cuts out. So let's see, decreasing the frequency. Yeah. So once it gets below a certain threshold, it turns the beam off. Cool. Nice job, HP. Let's see, do I have DC offset? I'm wondering why it's only on one side. I thought this would have an AC output, so it'd be going between the two. Yeah, I'm not sure. Oh, okay, this... Well, this must be output level. Okay. I haven't used this generator in a while. That's a weird halo effect up there. So let's see, X position. Let's move it that way. X gain. Got the gain down. Let's lower the level on the generator. Just trying to get it so it's just... Oh, interesting, we have a dead spot in the middle. Oh, it's a sine wave? So is it moving too slowly in the middle so it's cutting it out? So if I lower the frequency, does it... Yeah, more and more goes away. If I increase the frequency, it comes together. Very cool. Yeah, so a sine wave travels rapidly at the ends, but in the middle where it comes near the 0 point, the slope, it's not changing as much. So see if I got a triangle wave, there we go, linear. Alright, cool. so that's working. Let's see, cut down the X gain a bit more. Alright, so I'm going to swap my connector now and feed a signal into the Y input. So that should disappear. And nada. Turn the intensity up. Yeah, we're getting nothing. So it's not detecting any change in the input on the Y. It's just turning the beam off. Game over. So we know we definitely have a problem on the Y amp. And now we're back. I don't know how well this camera's picking up, but man, that is a gorgeous shade of blue. Alright, so let's power it down. I'm going to pop that board out. And at least let's examine it for now. I don't think I'm going to fix it. Well, one, I have no replacement parts on hand if it needs a new transistor or something, but at least we can take a look at it. Now I realize what I was saying doesn't really make sense, does it? About a sine wave, it actually changes more slowly at the extremes than it does in the middle. But yeah, once we get this thing fully functional again, we can play around with that some more. So I want to take this board out. In order to do that, I got to take some stuff off. Huh. There's a whole bunch of neon bulbs in there. It's kind of wacky. I better take some reference photos. Really screw things up. Because I need to pull some wires out of this thing to get it out of here. Alright, so a couple little guys over here. Oof. It's not soldered on, is it? It's just been on here for decades and doesn't want to come off. Okay, let's try pulling one of these off. Yeah, there we go. Everything looks to be gold plated and conformal coated, which is just gorgeous. No one uses edge card connectors. There are still plenty of wires plugged in. Not the easiest thing to get out. Those are all off. Right here in the middle, that off. This just leaves these two on the end. Do not want to move. Oh, there we go. Oh. There's the other one. Alright. Would be nice if they had some levers on these to pop the boards out because it's still that edge connector. Okay, it's moving a little. Whew. And there she is. Oh, it's a film capacitor. I was wondering what this thing was. It's a 1000 picofarad 8000 volt capacitor. I got that board cut out. High voltage thing there. We got all these neon bulbs. Some type of coating. Yeah, man. That is something. There's that switch I was talking about. So where does one even begin with something like this? Well, first thing I want to do is correlate what I'm looking at here with the schematic and identify the X versus the Y, because, well, the X is working. I don't want to muck with that. Assuming this board even has both X and Y on it. And oh, I am wrong. This is the Z-axis amplifier. So the intensity modulation. Oh, there are extra switches up there. Okay, I didn't see that. Alright. Well, crap. I don't know which is X and which is Y. I hope it's labeled on the board. Yeah, no, it's the inner board I need to get out. It's this next guy, which also has a switch now that I look down in there closer. I'll pull out the wrong board. Yeah, output amp. I can see that. I think I better look at the service info. Well, I reviewed the service info, and unfortunately the scans of the pages where they have photos showing the insides and identify the cards is a little fuzzy, but I do believe this is the Y-axis side. So this would be the input amp for the Y-axis. Nothing obviously jumps out at me as being blown apart or anything, but who knows. And actually, one thing does look kind of curious to me. Kind of looks like this has been replaced, but the soldering on it looks subtly different from other parts. Doesn't seem to have flowed that well on the top side, and on the underside these look like they've been clipped, maybe, but that's a stretch. I'm not sure. And it looks like it's a dual FET, so that'd be a fun item to try replacing, but potentially that could be bad. Now, another possibility is that the output amp is bad. That's where that riser could come into play. But I'm also wondering if both channels are really identical. I could leave the output amps and swap the input amps. Sorry, leave the output amps in place and swap the input amps and see if it changes. So let's take a closer look at that. And I get to put this back in. And I'm also curious to take a look at that riser and see if indeed that will allow me to monitor the cards while, so I can troubleshoot this. And oh man, I took a brief look at the adjustment instructions for all these along the back. Wow. Yes, those are for focus and astigmatism and all that, to get a uniform trace across the entire front of the set. In front of the screen. I do not want to have to mess with any of that stuff. I traced out the wiring to the BNC connector on the back, and that was absolutely the Y amplifier board. I put the Z axis board back in. Now I'm proceeding to pop out the board on the other side. So I'm going to compare the boards, check out the part numbers on them. If they are identical, then yeah, I don't see any reason why we can't. I just want to check out riser board. So yeah, see, just straight pass through. So that will be invaluable if it comes down to doing some troubleshooting with a scope. Let's leave that out for now. And I want to get after this guy. Man, I bet they have a tool for getting these boards out. Sure looks the same. Let's see. Yeah, I mean it would it makes sense to help. Yeah, and a couple of these have broken, or maybe they're meant to come off. No, they broke. Yeah, the plastic on these has gotten really brittle. So, oh well. So there we go. COS2 Rev D 4840 input amplifier 1317-66503. Yes, they're identical. So the one in my right hand is the x-axis and this is the y. So let's swap the two and hook everything back up and give it a whirl. And if it's still, I mean, if that gets the y-axis working, then we know what board has the problem. And I'm going to call it a night and post the video. And I'm going to resume troubleshooting at another time because it's getting kind of late. Let's pray. Okay, boards have been swapped. Everything hooked back up properly as near as I can tell. So let's give this a try again. Go. Both boards have been swapped, wired back in correctly as near as I can make out. Got it back on. Not seeing anything. Just try turning up the intensity. It's weird. The whole screen is glowing now. I turn up the intensity. Like there's no deflection. But maybe it's positioned off the screen. Okay, yeah, it's down there. Oh, there we go. We have Y deflection. And we have no X deflection. Well, now we know where the problem lies. The problem is on that board. We have two boards. We can compare and contrast. Shouldn't be too hard to figure out, I hope. Especially with this extendo card that we have. We can probe around a little bit. We've got our service info. Hang on, wait a minute. Okay, we swapped the boards. We got vertical deflection. I didn't check to see horizontal deflection. So let me swap the cables around again and see if by some miracle of me swapping things around, it's working. Okay, we got a blue glow down here. Let's play around with the controls. Okay, X position and the blob is moving. Y position. Well, wait a minute. Okay, did I seriously just fix it by swapping the boards? I mean, it's not unheard of. I watch a lot of vintage computing channels, and it's certainly not unheard of to just take things out, clean an edge card connector, put it back in, and it's working again. But geez, by the way, I just get a nice shock. It's a nice static electricity builds up on this thing. All right, well, let me get two audio generators out and hooked up, and let's feed both channels at the same time and have some fun. Alrighty, so for our second generator, I'm going to pull out my Wavetech 183 here, which is the one that does sweep and all kinds of crazy stuff. Now they're going to be unsynchronized, so if this works, it's just going to be some craziness, but it should look kind of cool. Just going to find the end of the cable here. We go, 50 ohms out. Drop the frequency down a bit. Oh, yes. Let's increase that amplitude. Hey, where'd you go? Get back there. Hey. Alrighty. Let the insanity commence. So, let's see. Next position. Move it over. My position. And let's see if we can adjust the gain and fill the whole screen. So let's see which one is X. Alright, okay, that's Y. Let's increase the amplitude on X. There we go. And boy, we got a nice lasagous pattern going there, don't we? Get up that intensity a bit. What a thing of beauty. So all these years, I thought this thing was broken. And hey, if somebody had bought it off of me, that would have gotten one hell of a deal, because all I had to do was reseat the cards, apparently. Well, let's try some different stuff here. Different waveform maybe. Let's change frequency a bit. So what am I going to do with it now, aside from making crazy lasagous patterns? You can hook it up with a stereo and do left and right channels on the inputs. I could hook it up to, say, my HP1311B hiding back there, just like I've been doing with my Wavetech 1901, and use it for alignment. So however, you see the 1901 has the grid on it. It'd be really, well, it wouldn't be useful to use without a grid on the front of it. Or, most likely, I will get an XY card. I could get one of those clock things, or, I mean, these days, because, CRTs are cool, and some of the young folks seem to be enamored with them, so they've made cool little, like, Raspberry Pi boards and stuff. We can program all manner of things, and I've seen a lot of people hook them up to, like, a Tektronix scope in XY mode. All that stuff you can do on this as well. So I just increased the frequency quite a bit on both of these, and I'm going up even higher to give you some idea of how sharp the lines on this are. I'm zoomed in really close. I'll turn brightness up a bit, just to focus a bit. I don't know how this translates into horizontal and vertical resolution, but it's got to be in the thousands horizontal and vertical. It's just a beautiful thing to behold in person. So now that is going to be it for now. Thanks for watching while I ponder what to do with this thing.